is Suresh Kumar E, and my project is Soft Memory Repair Strategy for Communication System, and I am doing my project under the guidance of Mr. M.R. Bibit. The outlines of this project are abstract existing system, drawback related works, proposed methods, work done and discussion, software used, application, future work and references. And my abstract is, due to the increase in integration and percentage of system on chip, area occupied by the embedded memories has also been increased. The software memory repair strategy defines SDMA signal samples correction stored in the memory. Then samples of SDMA signals are base band signals. The memory fault detection and tolerance is done using the weighted bit sequence based on MSB and LSB. The memory considered in this work is embedded SRAM. The SRAM is tested based on MBIST techniques. And this is the existing system. Memory size in OFDM receiver is expected to rise. Then uses of MBIST mode for checking errors and functional mode for rearranging data. The repair strategy achieves a measured 0.15 dB gain improvement in the presence of stuck and memory faults for an additive white Gaussian noise channel. The impact of memory fault is minimized by permuting MSB and LSB data memory region contains fault memory cells. And these are the drawbacks. It requires existing MBIST infrastructure, existing forward error correction mechanism, and eliminating the fault via redundant and costly repair rows and columns. And these are the related works. The first paper is Fault Tolerant Embedded Memory Strategy for Baseband Signal Processing System, and the author is Vadim Smolyakov, and these are the co-authors. It was published in the year 2013, and the aim of this paper was soft memory repair strategy and permutation of data to mitigate the impact of memory fault. The advantages is memory area saving achieved by eliminating redundant rows and columns, and the advantages of this paper is requires existing MBIST infrastructure (FEC). Then a second paper is reliability enhancement and self-repair schemes for SRMAS with static and dynamic fault. The author for this paper was Jin Fuli, and these are the co-authors. It was published in the year 2010. The aim is to improve the reliability of the SRAM. Advantages is combining REC with BISR circuit, and the disadvantages are multiple read operation to detect fault. The third paper is ProTAR, an infrastructure IP for repairing RAMs in system on chip. The author is CD Wang, and along with Jin Fuli. It was published in the year 2007. The aim is provides infrastructure intelligent property IIP for testing, diagnosing and repairing memory. The advantages is time saving, customizable for users to choose redundancy algorithm. The disadvantages is effect repair efficiency. Next paper is evaluating the yield of repairable SRAM for ATE. The author is Marco Ottari. It was published in the year 2005. The aim is yield calculation methodologies for SRAM, and the advantages is provides high level of accuracy. The disadvantages is one-dimensional redundancy, or only one pair of memory rows are considered in the algorithm. The last paper is embedding infrastructure IP for SoC yield improvement. The author for this is Yervin Zorian. It was published in the year 2002. The aim of this paper was international technology roadmap for semiconductors projects that embedded memory will occupy increasing percentage of a SoC area in the future years. Next, these are the comparison of research works in recent years. These are the parameters, and this is the parameters that the details of the parameters that we obtained in 2006, 7, 9, 11 and then 12. And these are the proposed methods. Instead of OFDM module for testing, we can use SDMA module. For a soft memory repair strategy, MSB and LSB are considered to detect the errors and correct the samples. SDMA signal characteristics, demodulator sampling interleave ITL input test vectors. The memory is SRAM. And these are the SDMA samples signal that has been generated using MATLAB software. And these are also the same samples that we have been obtained using MATLAB software. And these are the memory repair algorithm. First, we are giving the clock as 1 and write enable also 1. And then we are giving the write address as 0. Then when we give the write address as 0, the input will be stored in the 0 place of the Y RAM. Next, the clock and the write enables has given the same values. Next, we are changing the values which we have given in the write address. Now we are giving write address as 1. Then the input will be stored in the 1 place of the Y RAM, that is the output. Again, when we give the write address as 2, the output will be stored in the second place of the Y RAM, that is output, and it will be written as like this in this sequence. Now we are making some changes here. Clock is given as 1, read enable as 1, write address as 1. Now we are giving the read address as 2. Now here we are going to compare the input and the output, and if there is any error, then we need to rectify it, and if there is no error, then we will conclude that the codings are correct and everything is fine with the tape. This is the 64-bit input along with the clock 0. Next, the 64-bit input has been written here, and now we are giving the clock as 1, and the inputs will be stored in the respective bits of the output, and we are going to compare the input and the output. If there is any mismatch, then there will be error. If there is no mismatch, then we will conclude that the codings are correct and the output is correct. And as a result, if there is no mismatch, then there won't be any fault in the memory. This is the Altera FPGA kit. Here we are going to dump the coding, and we are going to compare the input and the output, and we will conclude that there is fault, or there is no any other fault in the memory. Then these are the software used: MATLAB tools, SDMA sample generation, modeling Sim 6.5e version, algorithm implementation, simulation outputs. And in Altera Quartus 2 10.1e version, we will synthesize and we will use it for FPGA kit implementation. And these are applications, communication systems, and also we can use it for fault tolerant techniques. These are the future works: the error correction operation, 1 sample correction per clock cycle. This operation can be tried using n samples per cycle, so that the operation speed will be increased. And these are the references of my project.